have a wonderful speaker tonight, Kenneth Drake. And I'm going to kind of read off my cue card here, so bear with me for the introduction. But Kenneth is a native Houstonian, and was native to Houston proper until 1978, and then moved to Conroe. He's a sixth generation Texan with Cherokee roots. So that's pretty neat. And he's also a direct descendant of Giovanni Battista Hodorina. Hopefully I said that right. And he was
Odoron.
okay, thank you. And he was an Italian astronomer of the 17th century. He cataloged celestial objects prior to Messier. So very impressive. Um, Kenneth's hobbies include target shooting, hunting, photography, no astrophotography, gardening, and hiking. Astronomy was added in 1983. That love really began in his teen years as he spent many summers near Weches, Texas, under very dark skies. And he spent the last 40 years exploring many trees of the astronomical, or many branches of the astronomical tree. His talk tonight is entitled Filters for Enhancement of Visual Astronomy, and he's going to provide us with details on the eye as well, including the retina, iris, adaption range, dark adaption, rods and cones, and averted vision. He'll then cover the use of colored filters for enhancement of details on solar system objects, and he'll give the details on the use of interference filters for the enhancement of nebula, both emission and planetary. And he'll touch on the use of light pollution rejection filters as well. He'll also attempt to cover the meaning of bandpass and percent transmission. So without further ado, I'm going to stop my share and Kenneth, you should be able to, and I got to get some more people in here. So Kenneth, you are free to share your slides and present. I just, if I could, if everybody would please mute during Kenneth's discussion, that would be much appreciated. And if you have any questions, put them in the chat, and then I'll come back to those after Kenneth is finished, and we'll have a Q&A. So with that, Kenneth, I'll turn the floor over to you. Thank you.
Okay, great. Yeah, I started this astronomy thing in '83. I lived east of the Woodlands and had a pair of binoculars and got a Mag 6 Atlas and started perusing the sky and just loved what I was doing. So, you know, I've been doing it since then. Um, we're just going to talk filters mainly. I'll go to the next one here. The normal filters for color uh, and planets are just there's 6 or 7 colors, and they're mostly marked by their rat number, and that numbering system means nothing to me. But it's a little weird because the rat number that you get on the different brands and different uh, batch of filters, the rat number doesn't mean anything because the tint of the color density can vary from one filter to the next. Um, Choosing the right filter can help you uh, see more detail, not only in the atmosphere of planets, but the surface detail on Mars and the moon. Uh, so you can get enhancement by picking the correct filter. Um, you can you can buy a set of the 6 for anywhere from $20 to $50. Just, you know, they're you'll get the, like I said, you'll get the let's go back one. You'll get those 6 colors: the red, the orange, the yellow, the green, kind of a maybe a dark green, and a blue. Sometimes you'll get 2 tints of blue. So generally 6 filters, and you might get a neutral density filter. Uh, for $9, you can buy a pack of different color correction gel filters. And they have the same colors: red, orange, yellow, green, blue, purple, pink, whatever that is there, mahong. And those are nice because you can at least get a kind of a feel for playing with those. Um, you don't have to go out and spend $50 on a set from, one of the astronomy stores. You can also buy them at Amazon. And I've learned to be careful with astronomy gear from Amazon that just sometimes don't have it. Or you can spend a really lot of money and buy Botter planetarium color filters. And they don't use rat numbers. They use more or less the center of the bandpass to give you the color. So you can see on this table, you got, 610 is nanometers is red, and the blue is 535. And you can spend $447 for a 2-inch set or $279 for a 1 1/4 inch set, uh, which to me is just a little steep. We'll start with what they can do. A red filter. It's really kind of people say it's a Mars filter. It eliminates the blue and the green, and it's because of its low percentage of transmission, which is like 14%. It really needs to be used on larger telescopes, like 8 inches or up. Um, it's also said to be good for Mercury. I can't say that I've ever observed Mercury in a telescope, so I can't vouch for any of that. Um, it does a few other things, but primarily it's a Martian filter. It increases the contrast of the dust clouds and all that. So that's what it's good for. An orange filter, how do I get rid of this thing on the right that shows all the people in the queue? Does anybody know? I don't know.
Is
Yeah.
it gone, Kenneth?
Yeah, over on the right-hand side, it's got,
Okay. Good. Go up to the top of that section,
okay,
and there's one that says, not that, yeah, that view button at the top,
hide
and
thumbnail. Okay, that worked.
Okay.
Yeah.
oh, we're still seeing it. Oh, that's mine. Never mind.
Yeah, I was just looking at the
Yeah.
text. I've got a cheat sheet here. The orange filter basically improves your blue-green portions of the spectrum, or limits. It cuts them out. Um, the blue-green and the red-orange areas of Mars are enhanced. The haze and the cloud penetration. They say it's good for Mercury. I don't have any knowledge of that. It will also improve some of the belts and the polar areas of Jupiter. It's got a 46% transmission, so it's actually could be used with pretty much any scope. The next one is a yellow. I'm going down the Roy G. Biv, the rainbow thing. Yellow boosts contrast on Jupiter. It will darken the blue festoons that appear near the north equatorial belts, south edge, and the equatorial zone. It enhances contrast of the blue-green features of Mars, and it will brighten the desert regions and darkens the bluish and brownish features. So these are the primary filters you should buy if you're going to spend time looking at the planets. Um, the 56 green has got real low transmission. It's got 24. And you can get darker versions, a number 57 or a 58. They enhance the dust storms and the ice caps on Mars. They'll enhance frost patches, surface fogs, and polar projections. And this is true. I've used green on Mars. Um, it'll also help with the rings of Saturn and the belts of Jupiter. You can strengthen those enhancements by simply darkening the filter. So go to a 57 or a 58. This is a 80A is a common filter that's used for a lot of things. But the deep blue is the one that I would recommend because it's 29% transmission and it'll bring out really, really incredible detail in the cloud belts of Jupiter. It'll also improve vastly. Now I'm talking about the number 50 now. It's a deeper blue. It'll help a lot with the great red spot. And if you have larger than 10-inch scope, the 38, which is even darker. It will help with the cloud contrast on Venus. That is something I've not tested. So good luck with that. But I would suggest it. Here's another filter I will suggest. It's a violet filter. It's a number 47. It has only 3% transmission. So it's a very, very dark filter. Nope, not that one. It's a great choice for isolating the polar ice caps on Mars and for bringing out subtle details in Venus's upper atmosphere. Again, it requires a large scope because a number 47 is very low transmission. I would definitely add to your little collection a W30, which is a magenta filter. You'll get more Mars enhancement, especially the Martian clouds. The white ovals in the south equatorial and temperate belts will be enhanced on Jupiter. You may get some enhancement from the rings of Saturn. Due to the fact that Neptune and Uranus are bluish or greenish, and you can get that kind of a effect that makes them look redder. A magenta filter will really help with those. So you can buy it as a separate, literally a separate filter. So consider adding one of those to your collection. I want to talk a little bit about the eyeball. Because this is where we humans are doing all the work. So you look through your telescope and you put your filter on and you project that image onto your retina. It's made up of several things. A cornea, which just protects the eye, the muscles that change the shape of the iris, which really restricts the light that comes into your eye. And what I mean there is like if you're looking outside and you look at the window and it's bright sun, and you just immediately divert your attention to something inside the house. It's much darker inside the house, but your iris immediately changes its size. So it adapts quickly. The lens of the eye obviously will focus the image onto the retina. The retina is just a thin layer of light sensitive cells at the back of the eye, which converts the electrical signals and sends them to the brain through the optic nerve. We are, being humans, we darken that pretty quick. Maybe 20 to 40 minutes when we can see pretty deep. We're not nearly as good as my cat. He has a great advantage. He has much higher concentration of rods than cones. His pupils get much larger. He also has a layer of material behind his retina called a tapetum, and it is a membrane that takes the light that comes through the retina and bounces it back through the retina to improve the dark, the low light capabilities of his eyes. So he can see way better than I can in the dark. He can't see in the dark, but he can see in much dimmer light than I can. Even though my range of vision is said to be have a dynamic range of 1,000,000,000 to 1. That's like 30 f-stops with your camera. Um, my cat needs only 17% of the light that I need to see in the dark. The human eye has a really large range, a dynamic range. It's said to be 30 f-stops or 1,000,000,000 to 1. I don't know if that's right, but that's what I've read. Our eyes work in 3 different ways. They work in the photopic, which is what our eyes use in well-lit conditions. We see color. We have cones for that. The mesopic vision is a combination of photopic, where we're using the rods, and cones, and scotopic, which is where we're using our rods. So we have a combination of low light and color, kind of like medium light. So the difference in f-stops between these 3 is about 10, between 8 and 10 f-stops each. So that's the range. You get this feeling that you're seeing deeper than you really are. So, but we were really interested as amateur astronomers in scotopic. Unless you're working with a camera and you're sitting there looking at a color screen in the night and you're just driving your camera. This is just about visual operations. We use scotopic vision, which uses rods, and the rods litter the back of the retina. Um, we don't have good resolution, and we see things as more just gray with scotopic vision or rod vision. But we have way, way more rods than we have cones. Actually, we have a lot of cones, but they're concentrated at the very center of vision. It's called the fovea. It's where our detailed vision is, and it requires high illumination. The rods have higher, they're just way more of them. Excuse me. The concentration of the photopic vision, which consists of the cones, only occupies less than 1 degree of your field of view at the center. So it's high res color vision. We don't use any of that when we get dark adapted. We're using only the rods. And then this little graph, it just shows how the cones just fall off. The numbers just disappear. But the rods are much higher when you get several degrees off the fovea. The documentation says 18 degrees off axis is the best area. What this shows basically is that the scotopic vision is much more blue sensitive than the photopic vision. I'm sorry, I got it backwards. No, yeah, photopic cones is different than scotopic. I'm sorry. Scotopic is more blue sensitive. This graph here shows that basically when you become dark adapted, and the more you're dark adapted, the rods pick up and have much more sensitivity to low light than the cones have. And again, they're offset a little bit color-wise. In very low light, only the rods supply input to the optic nerve. Dark adaptation typically takes from 20 to 40 minutes. And I've been in situations when I was young in high school where we were cave exploring, and we would literally turn off our lights and sit in the dark for 20 or 30 minutes. My brain played tricks on me. I started seeing little flashes that looked like lightning that were short. They weren't part of my vision. I wasn't seeing anything in the cave, but my brain was trying to make something happen. Different angles from the fovea dark adapt at deeper depths. So when we're getting dark adapted, the deepest dark adaptation occurs at about 10 degrees off axis. It's assisted by a process, a chemical process. Once you're in the dark, there's a substance called visual purple that takes over, and it starts flooding your retina and making it more sensitive. It affects the rods and it increases their sensitivity. The highest sensitivity occurs 8 to 16 degrees from the fovea. So if you're looking out, say you're looking out with your left eye, just close your right eye and look out there with your left eye. An area that's about 18 degrees, 15 to 18 degrees to the left of where you're looking, it's going to be more sensitive. So when you're looking at some kind of faint, fuzzy object, you want to place it to the left of your vision if you're using your left eye. If you look back to the right, or you concentrate in the center and then slowly try to see something, move your eye where you can look to the right with your left eye, you'll just a few degrees away, you'll reach a blind spot. And you can try it. You can just look at something on your screen or your computer with your left eye, but just slowly shift your vision to the right, and the object you were concentrating on will disappear. So you don't want to look to the right if you're using your left eye to look at some faint object. This is another way to just symbolize how off-axis has a much deeper visual simulation. You see 4 magnitudes on this, but with more dark adaptation, it can be higher than that. So just basically learn to use averted vision as another tool in your observing. And another thing we don't always take into account is integration time. When you look at something or you're looking at a faint object, you want to let that object reside on the same set of rods for more than a few seconds, maybe 6 seconds. It actually will build up an image and sensitize those rods so you can see deeper. If you just take a fleeting glimpse of something, you don't give yourself the benefit of your eye's ability. Okay, we're going to talk about interference filters. These are kind of my favorite toy, my favorite arsenal to keep in my box. And I've had them. I started buying them in '85, and the what they do is they only pass the light from nebula lines. So something at 5,000 angstroms, the filter is designed to peak at 5,000 angstroms, which happens to be the oxygen lines, oxygen 3 lines, where many of the planetary nebula give off their light. A lot of reflection nebulas, not reflection, emission nebulas do the same thing. There's also a line over at H beta. So you want a filter that basically concentrates the nebula lines and rejects the lines from light pollution. Another thing that people have to realize is that if you use a filter to just look at the object with the filter held in front of your eyepiece instead of screwed into it, be very cognizant of the tilt of the filter, because a tilt of the filter will shift its peak off where the nebula might be. And they design these filters to peak at the lines where you want to see stuff. And if you tilt it, if that line gets shifted, you may lose the ability to do that. See it. Um, well, I show you some things here. This is my favorite filter. Um, it's an oxygen 3 filter. It passes the oxygen line at 496, the oxygen line at 501, and also passes the H beta line at 486. So this is where it really concentrates its ability to see an object. And planetary nebula in particular emit a lot at those two wavelengths. And when at the TSP, I had made a list of objects I wanted to look at. They were all planetaries, but this is just a partial list with my 8-inch that I could not see. I literally could not see. Nada. Averted vision, integration, dark adapted. They were invisible. This little list right here ended up being my little list of no-see-ums. They were completely invisible until I screwed or put in an eyepiece that had a oxygen 3 in it. And they immediately became visible at various amounts. I mean, some of them were annular looking. Abel 33 and 34 were annular. I forget which one of these. One of these PKs was just a sphere. No central stars seen in any of them. They were all, the central stars were all too faint for me to see with my 8-inch scope. But if you buy one of these for visual, buy either a 15 nanometer or a 12 nanometer. They make more narrow band filters. That's where this line is, and it narrows down for photography. So you want one for taking pictures. You want to make sure that it passes only a 3 nanometer line or something for imaging, because you can change the exposure to pass that line. Um, Here's a list I made. Well, I didn't make this list. David nicely made this list many, many years ago. Um, my filter is an astronomic filter. It's a H beta. In other words, it it only passes the line just left of the two oxygen lines. So its peak is at 486 nanometers. That's the hydrogen beta line. And my filter passes 93.4%. Now, here's the funny thing. Astronomic in their webpage claims that they have a bandpass or a percent passage of 95 to 99%. Trouble is, if you buy these filters from Agena or some of these other wonderful big houses that sell astronomy gear, you may not get a 95%. And some people say, well, what's 2%? What's 2 or 3%? Well, maybe you won't be able to see the thing you want to see because you have a 2% less percentage of light coming through it. But anyway, this is one of my favorites. Not as favorite as the O3 because the O3 works on so many things. And the O3 will help these too. Maybe. And in fact, I know it will for some of them. In fact, you may have a more pleasing view with an O3 because it's going to pass, the stuff you need to see. Also, let's see, there's another one. The UHC is much broader. It passes the 496, the 501, and the 486. So it passes a high percentage of all the objects that we've been talking about. So you get a benefit from that. So you may get a more pleasing view. Your visual impression just may be better with a UHC filter. And mine is pretty old, and I'm going to get a new one. But I've got two that I use in my binoculars. They just stay in the eyepieces all the time. It's pretty neat to just scan the Milky Way with a 5-degree field and oxygen filters in it. Kind of cool. Here's an unusual filter. It's called a swan band. And mine's pretty old, so it covers these three, or actually it covers the 501 and the 5, I forget. Mine covers 496 and the 501. That's mine. And if you're thinking about buying a swan band, this is for comets. This is for the excitation of the gas, the C2 band. And it helps with some comets. But if you decide to buy one, buy a botter. They're the newest, and they cover the 511 and the 514. They just skip this 501 band, which is the oxygen line. And I've heard that they're better. I don't have one. I've not used one. But they concentrate their bandpass in the two bands that the comet gas is, or can be. Not all comets are gaseous. You'll go back to the oxygen filter. My best views ever using an oxygen filter, 12 nanometer bandpass oxygen filter, Thor's helmet, the Veil Nebula, and way, way, way many planetary nebulas are vastly improved, or in some cases made visible by an oxygen 3. So that's my choice of filters for interference filters. The swan band's kind of cool, but how many times are you going to look at a gaseous comet? Not many. Another filter I want to touch on is the light pollution reduction filter. They used to be pretty common, but they've gotten kind of specialized. And there's several new guys on the block. Astronomics makes this one that rejects these bands, which are light pollution bands, and passes these bands. If you decide to buy one, consider calling Astronomic and paying whatever extra you have to pay for postage, because you can ask them to hand select the best of their lot, and they will do that. I know that now for a fact. You'll get under 95% from the two biggies on the block. And I don't know about Lindsay and Sky. I've talked to them, and they seem to have a few, or can get a few filters. They will get you a TeleView bandpass, which is made by Astronomic. So you maybe look out and get one that's a high transmission. But you can contact Astronomic directly. They will email you, they will talk to you on the phone, and they will handpick a high transmission filter. Another one is a Oplong L Pro filter. It's pretty new. It basically does the same thing. It rejects the light pollution, uh, band pass, and passes the nebula lines. So you can see how it, it's got those peaks and valleys, and so it passes the stuff in here, passes this stuff in here. Apparently, it passes something here and here. I don't know what that is. It's also, you can use it for imaging, because they've added the infrared cutoff part of it, so that's supposed to help. I'm looking through my notes. Oh, we have one more, I think. Oh, these are the rat numbers, and these are all my filters. Um, you can get these neutral density in various shades, so you can darken the moon, or um, darken some of the brighter planets. Venus and Mars are pretty bright, so you can dim them down some. Um, these are filters I actually own, and those are the rat numbers for what it's worth. I don't know. I mean, like I said, you get the gel from Amazon for $9 and start playing with them. Just fool around, just hold them up to the eyepiece. Last but not least is solar filters. Uh, I've got an 8-inch Celestron. I've got a 4 1/4 inch f11 reflector. This is a Tut Hill. It's called a solar screen, SKREEN, and it's a double layer of high grade mylar. The This is basically a off the shelf Celestron white light solar filter, and this is one for a 50 millimeter finder. It's got the botter screen in it, and it came from Kendrick. Uh, that's it. That's all I got. Let's see. I'm gonna unshare. Got any questions out there? Let me do this. Let me go unshare. Who can start? In a minute. How do I get out of this share thing?
So there should be a button um, at the top, I
Oh,
think.
okay. I see it.
Yeah.
Okay. Okay. It's asking me if I want to share again.
Yeah, there you go.
Okay. I think I'm off.
All right. So Kenneth, appreciate that. I don't see any questions in the chat. So, but I do have one question myself. You mentioned earlier that you could you have put filters on binoculars,
Yeah.
and I was curious, are the binoculars special, the eyepieces special made to accept a filter like you'd put on an eyepiece on a telescope,
No,
or can you take like a standard? I use Nikon 10 by 50s that, they're just off the shelf binoculars. I mean, can you adapt those or buy an adapter that will allow you to put a filter on that?
I I bought a pair of oxygen filters from Botter, inch and a quarter, and I just used a tiny amount of silicone adhesive and dropped them down into the eye cup. My 10 by 70 Nikon Noctilux or whatever they're called
Hmm.
have eye cups that are shielded, so they wrap around the eye. And literally, I just took that pair, and I would put an H beta set in if I could find another set of eye cups. And Les down at Texas Nautical looked in his scrap heap, and he didn't have any, and they're not available. You can't buy them for it, which is a shame because they're still sold. The binoculars are still sold. Um, so just I took the eye cups literally snap on, snap off. I've got a pair
Okay.
for non the eye cup, non eye cup,
Okay.
and I have a pair for that have the eye cup, the
There you go.
wraparound.
So
And so I just
that's how you could get back to just regular viewing
oh yeah,
by
yeah. I
taking the
use
eye
the I
cups
use
off.
the regular eye cups for uh, just you know birding or whatever.
Okay.
And then my pair that's wraparound has the filters just spot adhesive glued in, so I can take
Got
them out. In fact, I'm going to take one out to compare it with my old oxygen 3 filters that I bought in '85.
Okay.
Which one of them, it's a Lumicon, it's inch and a quarter in it. I didn't show a picture of it, but it may be failing with the quote rust unquote failure.
Okay.
It looks like it has, but when you just look through it at the surroundings, it
Hmm.
looks like it's got the same view as my other oxygen. So I'm going to take one out of my binoculars and use it with basically the same eyepiece to look
Okay.
at something when the clouds go away.
Gotcha. Hey, we did get a couple of questions in the chat while you answered that. Scott Carnley says, great presentation. I'll echo that. And he asked, do you know how these filters affect people that are colorblind? Red slash
Oh,
green parentheses.
they would. I don't know that they would. And not the. They're all changing the contrast. So the color of an object like Mars or NGC 7000
Hmm.
is going to be, you're not going to see it in color anyway. And I don't know that, I guess you would Mars, but it would probably just do shades of gray. Like I have a friend in the UK. He's always whining at me because I send him these pretty pictures of stuff, and he goes, "Well, I'm colorblind, dude."
Hmm.
No, so he can't see the colors in a picture. But as far as the UHC and Swan, H beta, Oxygen 3, they're just changing the tone
Hmm.
because they're passing a certain wavelength, which will change the grayscale. Be my guess. I'd be glad to loan something to somebody if they want to play with it.
No, I appreciate that. So, Scott, did that answer your question?
Yes, it did. Thank you.
Okay, great. And Mike Nelson asks, can you stack filters or is it choose one for each view?
You can absolutely stack filters. Yes. I don't know that stacking an H beta and a UHC would be really good, but I've never tried that. But I've stacked, a yellow and a red. Yes, you can stack them. And
Okay.
I would tend to want to use really high quality filters. And
Hmm.
I'm not real keen myself on spending $279 for a set of Botter color filters, but they're they're probably of considerably higher quality and also centered on a specific band pass, maybe 25 to 40 nanometers wide, maybe
Hmm.
not quite as narrow as a oxygen interference filter or something, but
Okay.
they're, yeah, I would definitely try it. Uh,
Mike, any other questions?
Yellow and red do stack, and they improve the view.
No, thank you so much. Appreciate that.
Chris Shoemate has a question. He said, thanks for the presentation, much appreciated. Follow up on the binocular question. What filters are you using and what targets? Thanks
Oh,
again.
oh, yeah. Uh, with the binoculars, I use oxygen filters, and I only target things in specifically scanning the Milky Way, but also you can choose specific targets like the Swan Nebula or the M20.
Hmm.
Um, or I tell you what, Thor's helmet. That's a really a good one because you can view it with the naked eye or with the just your eyeball, and
Hmm.
you can put in an oxygen, and you can put in an UHC, and you can distinctly tell what you've improved in the view. Um, IC 468 is a big, sprawling, kind of like arms out in space, away from the Wolf-Rayet star that is IC 2359. So that makes up the Thor's helmet, I guess, and the arms of IC 468 protrude out away from it, and those pop with the oxygen filter. Whereas the UHC, it'll show the inner portion of the other one,
Okay.
the 2359.
What filters do you use if you're going to look at the moon? Do you just use illuminance to kind of knock down the?
No, yeah, and a neutral density.
Yeah.
The red filter probably will do some improvement on some of the landscape. Did y'all see that color picture that somebody posted the other day? An image of the moon that somebody had taken. It was like a billion megapixels, and it was taken with several telescopes, and it was taken with a whole bunch of different filters. It was just posted on our list server.
Hmm.
Oh, goodness gracious. Yeah, I thought I wanted to buy one, but
Hmm.
I don't have a space on my wall for it.
Hmm.
And literally, I have pictures that are taken by people that I know,
Hmm.
and I don't take pictures. So just if it's a bird, yeah, but no, none of this deep sky stuff for me.
Gotcha.
I can't do it.
Okay, so those are all the questions in the chat. Does anybody have a question? If you do, please come off mute and ask your question at this time. It's going once,
There you go.
going twice. All right. Well, I think
Yeah.
that's it then for the presentation. This will be recorded, so it will be available online. And of course, you can always contact Kenneth if you've got any questions. So I just want to wrap up the meeting, and I was going to give you some announcements before we adjourn for the evening. So let me go here. We have our special interest groups that will be coming up. We have next Wednesday the visual SIG. That'll be at 7:30 p.m. The Smart Telescope SIG will be Wednesday the 18th, again at 7:30. And in the astrophotography SIG, we'll have their meeting on Wednesday, June 25th at 7:30. You'll get an email from Stephen Jones with the link and the details. So keep an eye out for that, and you'll get the information you need in order to join. You don't need to register for those meetings, so you can go ahead and join once you get that link. And also be uh, tune in tomorrow night for the general meeting. Um, the topic for tomorrow night will be unlocking the chemistry of the heavens with Dana Quasim. I think, hopefully, I'm pronouncing that correct. And that will be tomorrow night's session. So, with that, I want to thank everybody for coming tonight. I appreciate your attendance. And Draco, we really appreciate your presentation tonight, and thank you very much.